Hello there, I'm Bruno Klaus. I'm currently a PhD candidate at the Federal University of São Paulo, more specifically the Institute of Science and Technology located in the city of São José dos Campos. Today I'm going to be talking about a very special challenge that I took part in recently. It was the Malay Data Challenge 2021. Promoted by MERCADO LIBRE. It is a competition that has been going on for a few years. Of course, the challenge is slightly different each time. So the challenge this time was to build a model to forecast item inventory days based on MERCADO LIBRE historical data. So basically, it is a time series problem in which we have to predict how long it will take for the stock to run out for a given SKU, which is the stock keeping unit. So the video will be structured as follows. I'm going to go briefly over the challenge, over this website of the challenge, explain data and valuation rules. Of course, MERCADO LIBRE already has a video, a workshop on that, which probably goes more in depth than I will. So you can skip to the other part if you want, where I'll talk about my experience with the challenge. Of course, I'll go over my solution, which is divided into 5 steps, 5 different Jupyter notebooks, if you will. And again, I will mark the video so you can jump to the part you want. But yeah, first let's go over the data. So here we can see we have a train underscore data.park, which contains our training data. And the image below illustrates what a row of the training dataset looks like. So here you can see it is ordered by SKUs, which is not a surprise considering that we will have to predict once for each SKU, of some selected SKUs for the test dataset. And for each SKU you have you see the attribute date. So the date goes from February to March 2021 in this training dataset. So 2 months of sales data at a daily level for a subset of MERCADO LIBRE's SKUs. And each row corresponds to a particular date SKU combination. So according to MERCADO LIBRE, you can think of a SKU as a combination of item and variation. An item could be, for example, a t-shirt of X brand, and a variation of it could be size M, color black. So we're interested in predicting the stock at SKU level because you could run out of stock for the color black, but you could have plenty of the t-shirt X for the color brown. Alright, so you have a few other attributes such as the price at that point in time, the sold quantity, perhaps the most important attribute in this kind of time series problem, and other discrete attributes such as listing type, shipping logistic type, shipping payment, and minutes active. Right, so also we have another file here, item static metadata.jl, which has other stuff like a bunch of IDs like item ID, item domain ID, site ID, product ID, and product ID family. Interestingly, I didn't find those IDs to be much useful this time. Last year they were immensely useful when you could actually make a graph out of it if you wanted and calculate some sort of features from that. This time I didn't find it to be that useful. Same goes for the item title, which is listing title on an item level. And now if we look at the evaluation and rules, you see that the chosen evaluation is the ranked probability score. So again, we need to predict how long it will run out, how long until it will run out of stock, beginning at April 1st, 2021. The thing is, we have the prior information that the stock will run out at some point in time during the next 30 days. So we need to predict a number between 1 to 30. Essentially we predict an output distribution. So how certain are we that the stock will run out from the first day and the second day up until the 30th day? And if we look here, we submit our predictions, our probabilities for each day, and what MERCADO LIBRE does, it sums up, it uses a cumulative sum. So for example, at the last day will necessarily be equal to 1. It will be the sum of all the previous ones. So this is the estimated cumulative probability that you see here. And then you have the ground truth, because the ground truth is, for example, okay, the ground truth was it took 3 days to run out of stock for this particular SKU, so everything after the third day will be equal to 1. Then we take this here, and we take the mean squared error, and we get the ranked probability score. The mean absolute error will be the square root of the ranked probability score. Right, so very simple metric to understand, I think, ranked probability score. And we can move on right to my solution, which is divided into 5 different notebooks. So you can see we will download and create the dataset. I actually saved, I kind of converted dataset to a file to make stuff faster to prototype and run. Then we're going to train an LSTM, a long short-term memory network model, then a light gradient boosting model, and then we're going to ensemble those models, or a few different models, since I ran a lot of those, and then I assembled them. And then, yeah, here last part is the dark arts, the leaderboard probing, which is basically I realized I was stuck at the, let's see those leaderboards again. Right, so at the public leaderboards I'm currently second. We have Mati Moreira at first here. It's a bit subject to shake-up, especially because of that kind of probing. But yeah, I was around here, 3.75, 3.76, up until I used the trick, because I looked at the Mercado Libre's own workshop, and they kept talking about the uniform distribution, and you see what exactly happened there. Right, so this is the first notebook in which we'll download and create our dataset. So to do the downloading part, it's actually real simple code. We just use the link available at Mercado Libre's website to download the data. And after we have downloaded the data, we will read the Mercado Libre files, put everything into a pandas data frame. So to do this, we just use the function to read the parquet. We'll add date as date time, and one very important thing, which is probably the most impactful thing on the leaderboard, I'll talk about right now, which is how do you divide your training data? Because as you see, for the test data, our task is to predict the beginning here. As let's look at the calendar. We start at the 1st of April, right? We have a given number of units that are our stock, which is this stock column right here. So say we have 10 units, that is our stock. Our task then is to predict how long it will take for those 10 units for this SKU to run out. And we assume that we begin at day 1 of 1st of April, and then say that it takes 14 days to sell these 10 units. So we train our model to give a very high confidence to this day 14, and it could be any of day between these from 1 to 30, because we do know that it ends, stock runs out in at most 30 days for the SKUs that are given to us, right? So we need to replicate that in some way, but instead of April, we need to go before. For April, in the test data, we'll assume that we have the last 30 days or something, right? We assume that we know the historical data for March. And then to train our model, we can start at 1st of March, and then we use the data for February. Except it wasn't like this, the vision I made. Instead, I chose to have available to us the days 1 of February to 24th of March. And why? Sorry, 24th of February. And why is that? Well, the thing is that this kind of data is such that items sold, they're sold more at, for example, the weekdays, the starting weekdays, let's say Monday, Tuesday, Wednesday, and then it drops off, and at the weekend very little units are sold. So the best thing I found in leaderboard wise was to kind of align. So say 1st of April, you see that it is a Tuesday. So when we're dividing the training data, then I chose it to be day 25, also a Tuesday, so that it is aligned, right? So it ends at, we have these days from 1 to 24, and then everything for prediction purposes, the first day is 25, right? We use the same stock as in the test dataset, which was the same kind of strategy used by Marufidio. I'll try to link down his video below. But again, if we have from some SKU we have 10 units, we need to know how long it will run out. We will do a kind of cumulative sum starting of 25 to see, okay, how long did it take to sell this many units starting at day 25. And if we see that by day 3 of March we have 10 units sold, in cumulatively speaking, then this is the target that we use, that we'll use for our models, right? Okay, it takes a little. It took me a fair bit to actually wrap my head around. And of course, Marufidio's video did help a fair bit with that. So props to the man. But that was the basic idea. But what I did differently was use day 24, 25 instead of 1st of March as the cutoff point. Other things of note is that I use this PyTorch geometric, which is a library built on PyTorch, which has this data loader, dataset, data functions, which to me I use it a lot. But you have to unfortunately download this external library as well to run this code. Okay. It has this dataset interface, and then here I can specify the modes: training, validation, or test. And just using the brackets, that is the get item, I can specify which SKU I want. So I say I want the 10th SKU, and it will give me the data related to this specific SKU. And the thing is, if it does that, we do have to do a fair bit of processing, as you see here, each time we call that. So ultimately, I found it best to use the pre-compute mode. So I instantiate the dataset right over here with this data loader. And for modeling, train, validation, and test, I'll just calculate, pre-compute everything by just using this for I data in this data set, and I just continue. I don't do anything. But because of the way the code is set up for this data set, it essentially is saving every sort of processed SKU to a different place in the list. And I ultimately save this list to a file, and then I use this save the list, which should be, let's see, Eclipse draft, not this one, many 2021 dataset. It should be like in the folder like this, converted, total of 3 gigabytes, I think. Yeah, you have one: train.pytorch, validation.pytorch, test.pytorch. And this is the final format that I use for my models, right? Okay, so everything noteworthy that I did, I think, about reading the data, I've already talked about. the rest is just lots and lots of code and minor stuff, uh, like changing everything to one hot, the categorical columns and so on. So I'll go to the next notebook. Okay, so now we move on to the second Jupyter notebook. And if you haven't run the first one, you can simply run these 3 cells to download the dataset and create the PyTorch converted dataset. But you use these .py files instead of running the first notebook. Okay, so once that is out of the way, you should have 3 files. Train.pt for the training set, val.pt for the SKUs there for validation, and then test.pt for the testing scenario. Okay, so each of those is a list, and each element of the list, for example, the first element of train.pt is something related to the first SKU, and in general, each element of the list corresponds to a different SKU. So we just create these data loaders to load batches of elements from those lists, and well, we'll have to feed them to our models, right? So these are the models that are used, at least the neural models that are used. So first up is the 1D convolutional neural net. It's the worst of the models that are used, I think, because it really didn't generalize so well, but you can see that we have here 4 one-dimensional convolutions, so convolutions over time. And then this goes to a 2-layer perceptron, so you have 2 linear transformations, of course, with the Licky-ReLU activation, and last one here, and then we just apply the softmax function to obtain probabilities that they will obviously sum up to 1. And here's one of the LSTM models. I have a couple of those. They don't differ too much from each other. The code for the other ones stored in some folder somewhere. But right, this one, I think it's probably the best performing one. So I compute some bonus features, such as it's the summarized features that are the mean. For example, you take the mean of the items sold for the last 24 days and you put it here in these summarized features, and then we wait a little until we use them, because first we just get our training data and we put it through these 2 layers here. There is this optional embedding for the domain ID, which I tried to use, but it really didn't work so well. But yeah, 2 layers, then straight into the LSTM. You can see the LSTM here has a hidden size of 32, and then from there you can get the last activation of last hidden layer. The last hidden layer of the LSTM. You take that, you concatenate with those summarized features that I computed dynamically over here, and you just use, I think, 2 more layers. And again, the softmax function get the probabilities. And lastly, I got this model from somewhere in the web, just an RNN encoder, which is, I think it's a GRU, very similar to the LSTM, but not quite. And then we try to use a decoder cell with attention. So we just combine the RNN encoder with the attention decoder, and we get this, the encoder-decoder wrapper, which I thought that maybe could be better than the LSTM, but in the end the predictions were pretty much identical. Okay, let's move on to the training loop. So we choose our model over here. You can see the custom mean squared error, which I used to compute the ranked probability score. You can see that because we output probabilities, we have to sum those to get that cumulative probability, and then simply the mean squared error. Okay, So from there, this is the simplest training loop ever. Okay, I ended up creating the data loaders again, but nonetheless, we just run for the training set validation, and we print out the average loss, and if the average loss for the validation set is minimum, we save this somewhere. Yeah, we save it right. No. Yeah, we sum it right over here. Yeah, bestmodel.pt. That's where we save it. And I think this here also uses TensorBoard. It uses a kind of a summary writer to write to TensorBoard if I wanted, in case I wanted to see how well training was going. But it wasn't needed. It goes reasonably fast. The slow thing is to actually read the file, because currently I have an HDD that is very slow. But here I've just run this part of the code just before. So we start here with the average loss of 3.65, 3.49 for validation. Here it's the average over the entire first epoch, so it's a little bit higher for the training. And yeah, we just run this for a couple iterations, and it goes lower than it ever goes for the leaderboard. So I don't think they match up exactly. But yeah, but nonetheless, we end up with something like 3.438. Okay, and then once we have that, I just interrupt it by hand usually. From there we can just load the best model and just compute the predictions for both the validation set and for the test set. Okay, so now we're on to notebook number 3. Once again, we're going to be loading our training data, validation data, and test data, this time onto the CPU instead of the GPU, and we create our data loaders once again. Then we run this to extract summarized features for light gradient boosting and save them to a file. So again, we have one more dataset for good measure. This time we extract features specifically for light gradient boosting. For example, here calculate the weekday distribution. So I want to know which percentage of items of that SKU was sold on a Monday, on a Tuesday, on a Wednesday, so on. And also this very important feature, days no sold. It's simply it counts how many days since you last bought, since anyone last bought that SKU. That turns out to be a very important feature. But yeah, standard stuff, we just create, save 3 files, I think. We save some metadata in a data frame, and we also save 2 arrays for features and also targets. So now we can load those features and targets and train our model. So yeah, it's a light gradient boosting model using the light GBM library. We just create the dataset class, instantiate the dataset class from light GBM, and our parameters is 31 number of leaves, obviously 30 classes. So we run it for 2000 rounds with this learning rate 0.025 with a very small bagging fraction of 0.02. So let's just put it to 500 here. Yeah, that should be enough. Okay, so it's running. After a while, it should be done. Okay, so as you can see here, we have let it run for 500 iterations, and let's try to then just calculate the mean squared error on validation. Okay, so you can see we got around 3.50, which is alright, a little bit more than the long short-term memory network and the attention decoder model. And yeah, and it keeps running because we also need to predict the test dataset. And then we can use this cell right over here to simply output our predictions to the to a CSV file. Okay, so finally we arrived at the dark arts, truly the Satsui no Hado of the competition, at least for me. But yeah, the idea is actually really simple. You just read the CSV to check the distribution of the output, and here you can see this is the target distribution of the prediction. So it starts it starts right here at the top, and as time goes by you can see there is a clear trend downwards. But if you remember the MERCADO LIBRE workshop, they said, oh, the uniform distribution was really good. So this prompted me to ask myself, well, it is going downwards, maybe I could introduce some sort of bias and make it more like the uniform distribution. Just try to make this this a little bit more straight, and that is what I did. So okay, this is the you can visualize the histogram of validation labels, not too important. So this is the post-processing. It seems that the solution performs well on leaderboard when we do one of the following. A. Multiply each of the days 0 to 30 by a multiplier, which is a line space interpolated from 1 to some value. I think it was something like 2.0. Actually it was, I think, 1.9 that I used. And divide each column by its mean. So the version I'm using here, I think, I try to make, in spite of being the uniform distribution, I try to give more weight to some days in which it was, for example, I tried to make it so that on the weekends we still had less confident predictions. So it's basically, it ends up like this, okay? So weekend, start of the week, goes back down, goes back up, and so on. But it's all based on multipliers. I mean, you didn't even need to use this. You can just take a line space, that is, you multiply the first day by one, so it stays the same. The last day you multiply by 1.9, and between those days you just use a linear interpolation. So the later the day is, the more confidence it will receive compared to what it was before. And that was enough for me to go from 3.76 to 3.71. Again, I think it's a calculated gamble. I have zero experience with doing this kind of stuff. Any kind of leaderboard probing, I'm really not a fan of it. But you're gambling one way or you're gambling the other way, basically. And I chose to gamble this way. So we'll see if it pays off or not. But anything could happen. But that's it. It was really a lot of work. But I think it was worth it, because I got to learn a lot of stuff. How to deal with time series. I had no idea how to do this training and validation split, and I'm still not totally sure. It could be different stuff, could lead to different validation splits. Yeah, I still have to search that a little bit. But anyway, that was my approach. Hope you can learn something from it, um, and maybe see you next year for the next Melee Data Challenge. So that's it. Thank you for watching this video. I want to ask you to like and subscribe and ring the bell because I barely upload videos on this channel, only once in a while, and usually related to research. But yeah, hope you enjoyed the video. See you then.